There is a place in space where the sky is blue, where oceans move, where clouds form and dissolve over mountains you have never seen, where, if you stood on the shore of its seas and closed your eyes, the wind might feel almost like something you remember, almost like home. NASA knows where it is, and they are not telling you. Close your eyes for a moment. Forget everything you think you know about what's out there. Forget the cold, the dark, the vacuum. Forget the textbook diagrams of distant gas giants and dead rock. What I'm about to tell you did not come from science fiction. It came from a telescope, a real one, pointed at a real patch of sky. And what it found should have changed everything. It didn't, at least not publicly. In 2009, NASA launched the Kepler Space Telescope into an orbit around the Sun with one singular, almost desperate mission. Find other Earths, not metaphorical ones, not potentially habitable ones buried in a footnote, real ones, small, rocky, warm, wet. The kind of planet where, if you were standing on it, your body would not immediately try to die. For 4 years, Kepler stared at a single patch of sky containing over 150,000 stars. It watched for shadows, tiny, rhythmic dimming that meant something was passing in front of a star, something the size of a world. And what it found was staggering. Over 2,600 confirmed exoplanets, thousands more candidates, and buried inside that data, a category so specific, so close to our own measurements, that scientists had to invent a new term for it. They called them Earth analogs. And here's the problem. Not all of them have been released. In 2014, something happened quietly inside NASA's data centers. A portion of the Kepler candidate list, not the full catalog, just a portion, was flagged, held, pulled from the public database under what the agency described as a need for further vetting. This is normal, they said. It happens all the time, they said. Raw data is messy and requires careful analysis before it means anything. Except this particular batch of candidates was withheld for over a year. And when astronomers outside NASA began asking questions, the answers they received were careful, measured. The kind of careful that makes you understand something is being carefully avoided. What were they vetting exactly? What were they afraid to confirm? Think about what it would mean. Not scientifically. Forget the science for a second. Think about it the way your body would feel if someone sat you down and said, "We found one. There is a planet 1,400 light years away, the same size as Earth, the same temperature as Earth, orbiting a star almost identical to our Sun. It has water vapor in its atmosphere. Its year is 385 days long. You would want to know everything about it, every detail, every photo, every measurement. But here's where things break down. Because if that planet exists, and if it is truly habitable, then the next question is the one no government on Earth wants you to spend too much time sitting with. Not can we go there? We can't. Not in any human lifetime. Not with any technology we have or will have. The next question is something older than space exploration. Something that lives in the part of your brain that still gets afraid of the dark. Is something already there? Kepler's most tantalizing find. The one that made astronomers go quiet in press conferences. The one that generated internal debates at NASA that lasted for months. Was a planet called Kepler 452b. Announced in 2015, described publicly as Earth's bigger, older cousin. An exoplanet 1.6 times the size of Earth, orbiting a G-type star, sitting squarely in what scientists call the habitable zone. Not too hot, not too cold. The kind of orbit where liquid water could exist on the surface for billions of years. Billions. Do you understand what that word means in this context? Earth is 4.5 billion years old. Complex life here has existed for roughly 600 million years. Kepler 452b is estimated to be 6 billion years old. That means if life started there the same way it started here, it has had 1.5 billion more years to develop, to grow, to build things, to look back. 1.5 billion years is not a small number. 1.5 billion years ago, the most complex life on Earth was a cluster of cells in a shallow sea. Whatever might be on Kepler 452b has had 1.5 billion more years than we have. But that's not even the worst part. The worst part is the signal. In August of 2016, a radio telescope in Russia called Ratan 600 picked up something unusual while scanning the sky near a star called HD 95128, also known as 47 Ursae Majoris, a strong, narrowband radio burst. The kind of signal that doesn't come from natural sources. The kind that, if it were coming from another civilization, would be exactly what we'd expect to receive. For 11 months, the astronomers who detected it said nothing. They tried to reproduce it. They analyzed it. And then they quietly notified a small group of SETI researchers with a message that was, by all accounts, remarkably understated for what it described. The signal was not repeated. By the time the world's major radio telescopes were trained on the same coordinates, it was gone. It has not returned. The official conclusion, unknown. Possibly terrestrial interference. Probably nothing. But probably nothing is not the same as nothing. And the coordinates of that signal are not far from a cluster of stars that Kepler was watching very carefully for a very long time. Let me take you somewhere for a moment. Imagine you are on a ship. Not a spaceship, just a ship. You're crossing an ocean you've never crossed before, at night, with no lights on the horizon. The water is calm. The sky is enormous. You are completely alone. And then, far off, maybe 2 miles ahead, is a single light, just one, steady, not blinking, and then it goes out. Did you imagine the light? Was it a boat, a buoy, something else? You don't know. You only know that for one moment something was there. Something was out there with you, in the dark, and now it isn't. Or it is. It's just not showing you its light anymore. That is where we are with the second Earth. Here is something they don't put on the press release. When a planet is identified as potentially habitable, the next step in the process, the step that happens long before any public announcement, is what's called spectroscopic analysis. Scientists point a spectrograph at the planet's atmosphere during transit. The light from its star passes through that atmosphere and reaches us. And the absorption lines in that light tell us exactly what gases are present. Oxygen, methane, water vapor, carbon dioxide. The chemical fingerprints of life are not subtle. They are loud. They are obvious. A planet with the right mix of these gases is not just habitable. It is inhabited. And if you found that, if your spectrograph came back with a reading that looked exactly like Earth's own atmosphere from 3 billion years ago, what would you say? Who would you tell? How do you write that press release? How do you say the words out loud without understanding what they mean, without being certain, without knowing what comes next? This is where something breaks inside you if you think about it too long. Because the distance is the thing that should comfort you. Full 400 light years. Kepler 452b is full 400 light years away. That light you're seeing from it right now, the light telescope is catching. The light carrying information about its atmosphere and its weather patterns. That light left that planet full 400 years ago. You are not seeing what it is. You are seeing what it was in the year 600 CE, before the printing press, before gunpowder. You have no idea what it is right now. And here's where time turns on you, quietly and completely. Whatever is on that planet has also been watching. If they have telescopes, and remember, they've had 1.5 billion more years to develop them, then what they see when they look at Earth is us some 400 years ago. A small blue planet with fires on its surface. Settlements. Things moving around on it. They already know we're here. The message they would send, if they sent one, is already traveling toward us. Has been for 1,400 years. Depending on when they sent it, it might arrive tomorrow. But it gets worse. In 2022, the James Webb Space Telescope changed everything. Webb can do what Kepler could only dream of. It can actually analyze the atmospheric composition of exoplanets in the habitable zone. It can look directly at the chemistry of another world. And in its first year of operation, scientists pointed it at a planet called TRAPPIST 1e, a rocky, Earth-sized world in the habitable zone of a red dwarf star just 40 light-years away. 40 light-years. Close enough that if we built the right antenna, a conversation could happen within a single civilization's lifespan. The initial atmospheric data came back in early 2023. NASA announced it was inconclusive. They said more observation time was needed, more data, more analysis. Several researchers involved in the project gave quiet interviews in which they described the data as unexpected. One used the word anomalous. Another simply said it was not what we predicted. They have not said what they predicted. They have not said what they found. Think about that word, anomalous. In every field of science, anomalous is the word you use when the data doesn't match any of your models, when something is there that shouldn't be. When you have a measurement that is correct, you've checked it 100 times. The equipment is fine, the math is right, and it still doesn't make sense. What is anomalous in the atmosphere of a potentially habitable planet 40 light-years away? What gas shouldn't be there but is? Here's the thing about the second Earth. The thing no one says out loud. Not at the press conferences, not in the peer-reviewed papers, not in the carefully worded NASA press releases. The thing that sits in the back of every astronomer's mind when they go home at night. If we found it, truly found it, with certainty, with atmospheric confirmation, with all the data pointing in one direction, it would not be a celebration. It would be the end of a certain kind of innocence. Because the moment you confirm life elsewhere, every model we have about the universe changes. The silence changes. The fact that no civilization has found us, colonized us, communicated with us in the 4.5 billion years we have been here. That silence which we currently explain away as distance, as rarity, as the simple statistical improbability of two civilizations existing at the same time. That silence gets a new explanation, and the new explanation is worse. If life is common, if second Earths are everywhere, if billions of years of evolution have happened in 100 different solar systems, then the silence is not absence. It is choice, or it is caution, or it is something we do not have a word for yet, something we don't understand, something that has learned to be very, very quiet for a very important reason. Fermi called it a paradox. A simple question asked at a lunch table in 1950 by a physicist who understood probability. If the universe is this old and this big and life is not impossibly rare, then where is everyone? The silence used to feel like loneliness. Now, the more we look, the more that second Earth comes into focus through our telescopes, the more the silence feels like something else. It feels like warning, There is a place in space where the sky is blue, and the oceans move, and something, maybe, stands on a shore and looks up at the stars. Something that has been here longer than we have, that has had more time to understand what is out there, that may have already found us in its own ancient telescopes the way we are now finding it. And it has gone quiet. It has turned off its lights. It has stopped sending signals. Because it learned something we haven't learned yet. Something the universe teaches every civilization eventually. The hard lesson. The one that comes after the discovery. After the joy. After the realization that you are not alone. The lesson about what it means to be found. The universe does not care that you are curious. It does not reward the civilizations that announce themselves. The cosmos is not a neighborhood. It is not a community. It is something far older and far stranger than any word we have for it, operating on scales that make our entire history a rounding error, indifferent to our telescopes and our radio signals and our small, hopeful questions aimed at the dark. We found the second Earth, and somewhere out there, something on that second Earth already found us back. The universe was never meant for us. We just haven't figured out yet what it was meant for.